So I'm with Wsol, and you're describing kind of the unified field theory underlying some of your...
Right. Okay, this is a unified field theory in hopefully 15 minutes that describes how all the forces of nature work. So science is about the attempt to take the chaotic diversity of our sense experience and make it correspond to a logically uniform system of thought. And this cosmic onion model I'm going to describe does just that. It's a logically uniform system of thought that in the geometry of these wave functions I can describe all the phenomena of things that what matter is, the forces of nature, and the properties of the vacuum of space. And the big problem in science is they haven't been able to reconcile Maxwell Planck's quantum mechanics with Einstein's relativity theories. And on a conceptual level, I do just that. And the problems with the equations go away because there is no such thing as a point charge in physical reality. So quantum mechanics deals with probabilities of, like, they don't know where the electron is going to be, but they can say, well, it'll probably be here most of the time. And by the density of the light there, you see in this particular orbital of this atom, that's where they would expect to find the electron. And so the dilemma is Einstein was hoping that the universe would be deterministic, but Heisenberg's uncertainty principle kind of varied that, and it has that's also included in the model. Now, just how twisted the invention of dark matter was, their theory. When they look out in the galaxies, they say our theory says that these spiral arms should be so twisted up that you can hardly distinguish them, and yet our theory can't handle it. So they have to start to invent stuff, add stuff to their theory, their model, to make their model work. The universe doesn't need dark matter. And there's actually a reason why the spiral arms aren't spiraled up. Is space itself, as it expands, it twists the gravity field. And so the gravity from here isn't pulling towards the center. It's actually pulling more kind of on the inside of the spiral arms. So that's why. And so then the invention of dark energy was invented because, again, their models needed it. As they look out in the universe and they think they're looking outward, what they don't realize is the further out you're seeing, the universe is smaller and smaller and smaller and smaller. And the way it got that way is if you think if the universe were going to expand, say, in a simplistic model at a constant speed, okay, then for the first day it would have gotten so big. So to double in size would take one more day. To double in size again will take 2 more days. And to double again, 4. And to double again, 8 more days. So each time the universe doubled, it took twice as long. So what I'm saying is when we look out, we're actually looking back the stair-step pathway down into the depths of time's past, into the depths of the universe. And we're seeing, well, these galaxies seem to be about this big, and they seem to accelerate as you look further and further back. It's not because they're accelerating, it's we're actually decelerating. Our clock rates actually are slowing down. As the universe expands, everything expands, and the Earth on its axis gets bigger and bigger, and the volume of space between here and the sun gets bigger and bigger. But we don't notice it because everything around us is at that same rate. So that was the invention of the dark energy, and you don't need it. It's actually because their perceptions of the universe are inside out. So the idea is you're trying to get a grasp in your mind of what's going on all around you, and it's like this fly is trying to get a grasp of the world around him. So what the current science thinks is that the galaxies were closer together and they got further apart and further apart. And yet when they look in their most powerful telescopes and they take pictures of the oldest galaxies, they're like, gee, that's funny, these are fully formed galaxies, not as mature as our galaxy is now. This doesn't make sense, and so they're surprised by what they see. Gravity only pushes things together, and so that's when, in that, I don't know if you've ever seen the filamentary structure of the universe. I won't get into that right now because I don't have an illustration to show you in this slideshow. But they believe that they understand 4% of the universe. 22% is dark matter, the part that they had to make up to, and they don't understand. And then 74% is dark energy, which they had to go and create this thing called dark energy. And yet it's because your perceptions are turned around. So if they took a class, and if I gave a class in cosmology and they got 4% of the questions right on their test, they would fail. Because the other 96% of what they think they understand is wrong.
Yeah.
And in this, I'm going to describe what causes redshift. There's Doppler shift, there's gravitational redshift, and then there's cosmological redshift, the actual expansion of space. Because they confuse the understanding of what Doppler is with the expansion of the universe, thinking that those galaxies are actually moving spatially. Nuh-uh. You could actually have a universe where all the galaxies are standing still and the space between the galaxies expands because the universe is expanding. That's what time is. Time is the expansion of the universe. All right, so I derived this stuff, by the way, in studying the Hebrew text of Genesis, and under the theory that God only knows how the universe was created. Well, God only knows because he was there when he created it. So down in the Hebrew text of Genesis, it describes Bereshit bara Elohim et hashamayim v'ata eretz. In the beginning, God created the heavens and the earth was without form and void. And I take that to mean the earthly realm of existence is like this firmament, what's called the ether, that they think doesn't exist, because the ether doesn't create a resistance in the spatial dimensions. It only creates a resistance in the temporal dimension, and that's where Michelson morally went wrong. They thought that, well, if we can't detect it, then it must not exist. The thing is, they didn't realize that their apparatus is incapable of detecting it, and so you can't draw any conclusions from that experiment. But this is basically what the model is if you have a pebble in a pond, you can make ripples move outward. A hula hoop in the pond, you can make inward moving ripples, but as they reach the center, they become outward moving ripples, and they become superposition, or they become a spherical standing wave. And so you get this pulsating onion layers. And so as these things are pulsating, light will actually travel in between those onion layers as if the onion layers are a conduit. And that's what a photon is a fragment of a wave function traveling in that conduit. And then for an instant, those onion layers are constantly vibrating, so they're like shutters opening and closing. And so when they open, that photon can go to the next onion layer. So that's what makes a photon not have mass, is it doesn't actually have to penetrate the onion layers. And when I describe what a particle of matter is, you'll see why particles have mass. So then God said, let there be light, and a spherical pulse of light would expand within those onion layers. So particles of matter, they're like spring-shaped waves. Like this is supposed to represent like a proton, where if you remember that those onion layers are this transverse wave oscillation. So they're a little circular motion that goes inward. And so these proton spring-shaped waves have an affinity for the outward ones, and the electrons have an affinity for the inward ones. And so as time's proceeding forward, the electron is getting, say, a left-handed spin, and the proton's getting a right-handed spin. I don't mind have my rights and lefts mixed up, but you get the idea. And so it's the ones that have an affinity for the inward spirals of the those onion layers. That's an electron. That's what gives it its negative charge. Because time's proceeding forward, that wave function for the electron gets all stretched out, and so it's like a stretched out slinky, whereas the proton is all scrunched up 1,862 times denser in the waves, those oscillations. than the electron. So that's the proton-electron mass ratio, and that's where the mass comes from. Is those oscillations actually create a crooked path. So everything's trying to go at the speed of light all the time. Everything, even ourselves. But the Planck time is so short. Those onion layers are on the order of 1.86 times 10 to the minus 44th of a second. And so that slows down, it creates so much resistance that it slows down the expansion of the universe. So you have that magnetic force constant, that K sub m. Well, that's the amplitude of those oscillations of those onion layers. In fact, I should go back to that screen. So the amplitude of those oscillations is the K sub m value, the magnetic force constant. Then you take that, if it's going in a circular motion, 2 pi times that is 2 pi times 10 to the minus 7th. And it's inward, so that's negative 2 pi, and the outward ones are positive 2 pi. The differential between those is 4 pi. Well, you take 4 pi times 10 to the minus 7th, what do you get? Mu sub 0, the magnetic permeability of the vacuum of space. So the geometry of this onion is now spelling out step by step all the physical constants that describe the vacuum of space, the ether, essentially. You take that times the speed of light squared, and you get the electric force constant that's used in the electric equation.
Now, you described some new forces too, right? A new addition to relativity as coming out of this theory?
There's a third relativity theory, and it affects our perception of time. But I'm going to save that one for last, because that's the one that's the hardest one to understand, because it twists your brain in ways that it's never been twisted before. So this wavefront of light that's one-time quantum thin that defines the current and moment of time we call now, I call it the now manifold. It's expanding through these onion layers, and when it does, it encounters the resistance of those onion layers. So you take the speed of light that it's trying to expand at, c, times the mu naught value, that differential of those energy waves, and what do you get? 376.73 ohms. That's the impedance of the vacuum of space. That's a Z sub 0 in the equations that they use to do like antenna designs, because the antenna is imposing a magnetic field into this vacuum, and that's where it comes from. So that is the surface of the now manifold, is a unified field. When you zoom in at the quantum scale and you watch what's going on with the quantum scale jitter motion and stuff, that is what's happening in the unified field. So when you have these particles of matter, what happens is that now manifold is sliding past those spring-shaped waves. And so there's an active-reactive interaction between those two wave functions. And so it generates kind of a whirlpool on the surface of the now manifold. And the way that whirlpool would look is a spherical standing wave around the particle. But it has a torque to it. And so, like the whirlpool, if the whirlpools are going the same way, the whirlpools tend to push each other apart. If they're going opposite directions, like a positive and negative charge, then they pull each other together. So now I've explained where the charge comes from in the particles, the electron having the affinity for those inward waves, proton outward waves, and what causes electromagnetism. So now we get to gravity. So if you have a whole concentration of atoms, we have to build up a few atoms first. You take a proton and a neutron and you entangle those waves around each other. And so wrapped up in the entanglement of those two waves is yet more curvature. And that's how a neutron is constructed. So wrapped up in that twisting of those two waves around each other, it accounts for the additional mass of the neutron. When you take a proton and an electron, add it together, it says, well, that doesn't quite add up to the mass of the neutron. Well, because the energy it takes to construct that entanglement. So you take a proton and neutron, you wrap it together, and you have a nucleon, the basic building blocks of an atom. You take the two nucleons and you have an alpha particle, a helium nuclei. nucleus. But at that point, you have to now start stacking these entangled things and start wrapping those around, and that builds up the atomic nuclei of the entire periodic chart by fitting 8 more into the next level and 8 more in that. And what that ends up doing is the neutron blocks part of that positive charge of the proton, and so it creates an interference pattern around the nucleus. And so the electron, being a negative charge, wants to sit down in the bottom of a dent if it could find one. Well, it creates these dents in the kind of hills and valleys in the space-time differential around the atom. So it's like inside these ridges of the whirlpool. So the next thing is to describe the 3 manifestations of redshift, or there's blue shift with special relativity. And it turns out each relativity has a redshift associated to it. And so that's how I discovered what the third relativity was, is I realized there's a third form of redshift that nobody's accounted for. Okay, so Doppler effect happens instantaneously while a wave function is leaving a source, a wave source. And what I picture that is those spring-shaped waves. As the now manifold is sliding past it, it's interacting with that wave, generating this expanding spiral whirlpool around the particle. And so that induces an oscillation into the surrounding media, and that's the emission of light, especially when that wave function drops. So another phenomenon of special relativity is if you take this cosmic onion model and say, okay, let's say the universe, this is now manifold at some instant in time, and here you have a particle, let's say that's an electron, and during that 1 second that the universe expands from here to here, that electron has a certain number of oscillations in the spring. Well, if that particle is at rest, it's perpendicular. But if it accelerates to 20% of the speed of light, then more of those oscillations will fit within that 1 second. So if you're an outside observer and you're still maintaining this reference frame that a second takes that many time quantums, then to you, looking at that mass as an outside observer, it would increase in mass, because the mass is the number of oscillations per second of penetrating those onion layers. And so it's resisting having to penetrate that represents a slowdown in time, which creates a dent. And so now if you have a whole concentration of those particles of matter in and around a planet, it creates a dent in the space-time manifold. But that's the increase of mass. So here's an example of a particle going half the speed of light. So it would have the square root of 2 times that much more mass, that many more oscillations per second. But if you're in the reference frame of that particle, your perception of time starts slowing down. And so it slows down by the exact same amount, so you always perceive your own rest mass to be your own rest mass, no matter what speed you're at. And so that explains special relativity. So then the distant starlight, there's gravitational relativity. So what I'm saying is this, a massive planet or star with all this quantum scale jitter motion, instead of that now manifold expanding through those onion layers straight out, it has to go in this like jitter motion. And so that increases the pathway that the expansion has to go through. So it creates a dent in what would otherwise be a perfect sphere. And so the more massive and dense the object is, the deeper the dent. The deeper the dent, the steeper the slope. And remember, this now manifold is actually penetrating those onion layers now at an angle. And so that angle represents a force vector that's created at that instant that's directed towards the bottom of the dent. And so you feel the resistance of the impedance of the vacuum is pushing you down towards the surface of the planet. And that's what causes gravity. I've never heard anybody be able to explain that anywhere, but this model does it so simple. In fact, I sit down and I ask the model question about things that I didn't know before, and it answers them. Because you can animate it in your mind, or you can animate it with mathematics in the computer. So, again, space is the 3D surface of this ever-expanding manifold. Matter is these spring-shaped waves that create this quantum scale jitter motion. And this slows the expansion of the space-time manifold in and around the object with a diminishing effect of distance. And the denser the object, the deeper the depth. The deeper the depth, the steeper the slope. And the steeper the slope of that space-time manifold, the stronger the gravitational field is at that point in space.